Here we need to find out how many constraints are there for the motion of cylinder relative to the flat surface. Now remember that this kind of a problem you have to first fix a coordinate system, though this coordinate system is given. So if it is not clear, understand that x and y are in the plane and z is perpendicular to the plane of the cylinder. So first you have to see how many there are total 6 degrees of freedom, right? 3 translations along x, y and z, and 3 rotations along x, y and z. So you have to first figure out along which it is moving. So then 6 minus number of degrees of freedom, or the free degrees of freedom where it can move, will give you the number of constraints. So let's see, along x-axis it can easily translate, right? There's nothing that can stop. The thing is that easily translate in the sense there might be friction, that's okay, but it should not, the condition is that the one material should not penetrate into the other. That is the condition for free movement or constraint. Okay, so if it moves along x, it is free to move, so it can easily move along y. Z, if it cannot move, because if it has to move in z, it has to penetrate into the cylinder block. It has to penetrate into the block. The cylinder has to penetrate into the block, so that is constraint. Rotation about x, well, that will be a rotation about cylindrical axis, because x is along the cylindrical axis, so that it can easily do without penetrating into the block. Rotation about y, well, if it has to rotate about this, then it has to go one part of that cylinder, it has to go into the block, which is not allowed. And rotation about z is basically a rotation within this plane about this, so that is rotation within the plane, so that is also allowed. So these are the constraints. Okay, so directly you can say 2 from here, or if you look at number of things allowed, so that is 4, so 6 minus 4, even in this way also you can say, so 2 is the answer. So it is constraint basically for the translation along the z and rotation along y axis. Thank you.